When you start a physics course, there is a lot of things you need to get familiar with. One of them is the system units that we use in physics, as well as in all of sciences. So in this video, we are going to start with looking at these standard units, the standard unit for length, for mass, and for time. But first, let's speak about measurement in physics. To describe natural phenomena, we must make measurement of various aspects of nature. Each measurement is associated with a physical quantity, such as length of an object. The laws of physics are expressed as mathematical relationship among physical quantities that we'll introduce and discuss through the book. In mechanics, the three fundamental quantities are length, mass, and time. All other quantities in mechanics can be expressed in terms of these three. So whatever is chosen as a standard must be readily accessible and must possess some properties that can be measured. Measurement standards used by different people in different places throughout the universe must yield the same results. We are going to start with looking at these standard units, the standard units for length, for mass, and for time, and the international standards, the Système International, as they say in French. In the SI system, we use the letter M to represent meter, we use kilogram, kg for kilograms, and we use letters S for seconds. Personally, I like to use SEC because it's a little bit more clear when you talk about seconds. Now, in some case, we need some additional basic measures, such as the basic unit of charge, for example, is the electron, of course, and the basic unit that we use in equation is the coulomb. And we'll see how we derive those later on. But we can do most things in mechanics by simply knowing length, mass, and time. For example, if you want to define force, we use the Newton, and notice we use the letter N to denote Newton, and the Newton is made up of kilograms, mass, and seconds, and meters. So the three basic units, length, mass, and time, are present in the Newton unit. Here you can see the definition of length. In the international system, the unit is meters, and meter is defined as the distance traveled by light in a vacuum during a time of 1 over the celerity of light. And mass in the Système International is in kilogram. It's defined in terms of a kilogram based on a specific cylinder kept at the International Bureau of Standards. Time, which is in seconds, is defined in terms of the oscillation of radiation from a cesium atom. So there is three definitions for time. Moreover, in physics, we may use some prefixes which correspond to power of 10. So if we are speaking of kilogram, it's 10 to power 3. So each prefix has a specific abbreviation. So kilo, it's K, mega, it's M, nano, it's N. They are multipliers of the basic unit. The prefixes can be used with any basic unit. So we can talk of kilogram or kilonewton. We can use these prefixes, but you should know that kilo is 10 to power 3. Finally, we can Moreover, in physics, we may, but you should know that finally, we can derive quantities. Derived quantities can be expressed as mathematical combination of fundamental quantities. So, if you are speaking about area, it's a product of two lengths. So, it's L times L, L for length. Speed is a ratio of length divided by time. Density is a ratio of mass divided by volume, and volume is L to the power 3. And as I said before, force, Newton, it's kilogram times meter divided by second square. So there are derived quantities, such as quantities are derived from fundamental quantities. In mechanics, the three fundamental quantities are mass, length, and time.